So we're going to start our review with the most basics of basic programs. The one you learn with every language, Hello World. So in C#, there are two commands to display text on the screen when we're talking about a console. Now we're not talking about any form-related programs at this point, which means we don't have to worry about labels or text boxes or anything like that. We're going to focus on the console right now. So there's only really two commands we're going to work with. And the first one is the most common one, which is console.WriteLine. And then inside the brackets, you just need to specify what you want to display. So for example, hello world. And don't forget to end your command with a semicolon. We run our program, and we should get our hello world on the right-hand side. And of course we do. Now, that's not the only one. We could write something else as well. So let's say we write console.WriteLine goodbye. Let's add a second command in there. So now we should get two output statements. Hello world, goodbye. That's great. But I mentioned that there was a second type of output statement, and that one is console.write. Now the question is, well, what's the difference? The difference lies in this thing right here, the cursor. So if I just write, let me comment this line out. If I just write goodbye on the screen, look where the cursor ends up. The cursor ends up on the next line. And that's important because what that represents is if there's any more output to come, that's where it's going to go, the next line. Now watch the difference between that and console.write. You see that the cursor is still on the same line. That means if we were to display more text, it should appear on the same line. So let's go take a look and try that out. Console.write followed by console.WriteLine. And there we go. We have them both together. So that may or may not be what you want. It depends on your program. So let's say, for example, you were creating a program that you wanted to display a table of data where every row represented a different piece of information for a given person or thing. So the first row might be like first name, and then, the first column might be first name, the second column might be last name, third column might be age, fourth column might be favorite color, or something like that. And let's say you had an array that represented all that data. So you could go through your array, each piece of information going in another column, and you would do that using separate console.write commands to make sure that everything stays on the same line. You wouldn't go down to the next line until all the data for a given user is displayed. And that's where that comes into play most handily. But we're actually going to see it in a few other places as well. So that's the most basic form of console.WriteLine, most basic form of output. Of course, this isn't all we can do. We can actually do a few other things. The most common thing would be concatenation. Concatenation is when we add on more text. So for example, I might write goodbye plus, I don't know, maybe the name Bob. Goodbye, Bob. Now if we run that, we get goodbye, Bob. You'll notice that I put a space here because if I didn't, I wouldn't get the space between bye and Bob. If you don't put it there, the program doesn't know to put it. Computers only do what you tell them to do. So if I don't tell it to put a space, it's not going to give me a space. So I have to be very specific with all my commands. Now I don't have to only concatenate text. I can actually concatenate other things, such as numbers. Concatenate 20. If I run this, we get goodbye 20. Again, I don't get my space. Let's try something else. Let's concatenate another number. Goodbye 20 plus 20. Well, what are we going to get on the screen there? Are we going to get by goodbye 40 or goodbye 2020 or something else? Let's find out. We get goodbye 2020. And the reason being is that it's concatenating those 20s like they're text. So we started with a string and it says, okay, add on to that something else. Since this is a string, it's going to assume whatever else we want to add on is also a string. So it's going to treat that 20 just like a string. Now, maybe I don't want it to be treated like a string. Maybe I actually want to do this math. Well, the only way I can do that is if I surround the math in brackets. So if we run this, we should get goodbye 40. Well, that's interesting Why did it do it this time? Because it follows proper order of operations, Bedmes rules. And in Bedmes, B comes first, which means brackets. So it's actually going to solve this problem. It's going to calculate the result of that expression before it does the concatenation. Other than that, it's just going to go from left to right. So it's going to say, take this string and concatenate it with, oh, we got to get that answer first. Concatenate it with 40. Now let's tempt fate for a second. Let's go on the other side of goodbye. Let's go like this. Let's say 20 plus goodbye. So now we're taking a number and we're concatenating it with a string. Well, what do you think we're going to get? We're going to get 20 goodbye again. Or 20 goodbye this time, I should say. This time the 20's on the other side. So it's saying I got a number and I'm going to add a string to that. Oh, that must mean that I want to treat that number like a string as well. Okay, fine. Now, if you recall, when we did this on the other side, we ended up with goodbye 2020. What are we going to get this time? This time it did the math. Now that's inconsistent now, isn't it? Well, what it really did was it followed order of operations, which means left to right, because we don't have any other things in here. So what that means is it says, oh, I've got a number 20. Add on to that another number 20. So it did the actual math of the two integers first, and it resulted in a 40. Then it took that 40 and it added it to a string. Oh, you must want me to concatenate. So it did 40 plus a string, which gives us 40 goodbye. So if I want, I don't even need the brackets here, but it is usually good form if we want to keep it clean and well written. Okay? So we got to be careful about when and where we actually do our concatenation. Is there anything else we can do with strings, basic-wise? Because there's a few more advanced things that we're going to do later on. But in terms of other basic actions, yes, there is. There's something called escape sequences or escape characters. And what these are, they're special pieces of text that we can insert inside of our strings, anything inside of quotes. We can insert it inside of there to get different effects. So there's a few of them. So I'm just going to put a comment here to kind of write them out. So the first one is /n, which means new line. The next one is /t, which means tab. And then there's a whole bunch of other ones for special characters. Things like, what if I actually wanted to put a quote inside of my string? Well, I can't just throw a quote right here because it's going to think that the end of my string is at the end of good. Then it gets confused and breaks things. So that's no good. So the only way you can actually get a quote inside of your string is to use an escape sequence. So /quote. And we could also do the same thing for a single quote. /single quote. All right? And there's other ones. Now, what if you actually want a slash? Well, then you need to do // And there's more as well. You can Google it and get a whole bunch of different results. So let's play with this for a second. Let's make this go down to the next line. So let's say good on one line and then by on the next line. So to do that, we're going to use the /n. So I'm just going to put it directly in the center here. /n. Good /n by. It's part of the string. So we run this and we get exactly what we expect. Goodbye. We have to be careful though, because remember, look at this. We have good space by. What if I put it right here? Or better yet, right here. And so I leave that space after the /n. Well, that space is going to go there. So we actually see that it got misaligned because of that, because we actually have that space in there. Computers do exactly what we tell them to, not what we guess what we want them to do. So if I had done it on the other end of good, though, would we have even noticed it? Well, that looks perfectly good. But if you highlight this right here, there actually is that space. That character really is there. Now, it doesn't look like it's a problem until you start doing things like playing with the background color behind the words and stuff like that, which you can do. You can customize colors, and that would actually show up as like a highlighted blank area. So it could cause you problems. So again, be conscious of this. So we can add extra lines in there. Maybe we want to add a few new lines in there. And you're going to see the by is down a few lines. Maybe we want to add a tab in there too. Make it go over. So you can see that we actually get tabbed over. Now, I believe in, So Yeah, it looks like it's 4 spaces. So a tab inside of REPL is 4 spaces. It's not considered a tab character. It's actually 4 spaces. So we got to be mindful of that. So that's all of our basic output. So we're going to leave that alone for now. I'm just going to put a comment, or I'm just going to put a group comment around that, /* and then //. And that will comment out that entire section. We'll put a little comment here that says output. So if you want to look at that. So the next thing we're going to talk about is variables. Now we know a lot of different types of variables, if you recall. So let's go over the different ones first. The first ones we had were numeric types. So anything that represents a number. So I'm going to write numeric. It's getting slow on me. So numeric variables. So what numeric variables do we have? Let's start with the smallest. The first one we have is a byte. It's called a byte because that's how much memory it takes up. It takes up 8 bits. And this one is good for anything from 0 to 255. So it's got to be positive, 0 to 255. Okay. The next biggest one that we usually work with is an int. Now this is a 32-bit integer. You can actually create 16-bit integers as well as 64-bit integers. You can also create unsigned integers. A regular integer, 32-bit integer, is a positive or negative whole number between about -2 billion to about +2 billion. So it's got a pretty big range of about 4 billion, but they're all whole numbers. The next one we look at is a float. This is also 32 bits, but the difference between an int and a float is that a float can actually handle decimal places. It still has about the same range of -2 billion to +2 billion because it's 32 bits, but it can handle decimal places. The next one is a double. It's called a double because it takes double the size of a float. This one is 64 bits. It is a massive, massive number. It works the same way as a float, though it can handle decimal places and positive and negative numbers. But its range is absolutely huge. We're talking 10 to the 308th power or something ridiculous like that. So it's a massive number, built mostly for precision. Maybe you're building banking or some graphical software, or maybe even like architectural software, things like that. That's where that's going to come into play, where precision is king. So those are all of our numeric types. The next ones we have are text types. So we know one major one, which is string. Okay, just string. It just represents a sequence of characters. So, for example, this would be a string. Hello world. Okay, let me put a comment on that. That is a string. We know it's a string mainly because it's surrounded in quotes. So that tells me that it's text. Just the same way as this is text. That is a string. It's not a number 555. It is a string because it's surrounded in quotes. Now, if you recall, a string just represents a sequence of characters where we can actually access each individual one of those characters using an address, like we use square brackets. So we'll come back to that in a second, but we can access the individual characters of a string. The other type that we talk about sometimes is char. Char is short for character, or one individual character. Now it is not a string of length 1, it is just a single character. So when we define a single character and we want to specify something, we don't do it with double quotes, we do it with single quotes. Oops. So that is the char character A. Single quotes. And we had one last type that we focused on, which was bool. This is simply any value that's either true or false. Oops, not false. So let's give this a little playtime. So let's create a couple variables. Let's say int num, and let's give it the value, I don't know, 5. And let's create a double. Let's say double num2, and we'll give it the value. Oh, this plugin crashed. That's not good. Hopefully it doesn't kill too much. Hopefully it'll come back up before we finish this video. So double num2, and we're going to set this to, I don't know, 7.5. And let's say, I'm going to copy and paste this just in case something goes weird. Copy this. All right. Now we can try and output these pieces of information. We'll do that with a console statement, console.writeLine, and I'm going to say number. Oh, it's crashing on me. Come on, you can last. Number, and we're going to concatenate number with our num variable. So you can see now we can use concatenation also with variables. And we're going to do the same thing with number 2. Console.writeLine. And we're going to say number 2. And we're going to concatenate that with num2. I kind of want to hit go, but I'm scared it's going to crash. But we're going to test it. Let's find out. Big risk, big reward, right? Let's find out. Oh, my run key isn't even there. Okay, I'm going to pause the video for a second while I fix this, and then we'll come back to this. Okay, so we're back now. I just had to reload the page, and everything is good to go again. So let's try running our program. And we see our two numbers get displayed, 5 and 7.5. So we can play with those numbers as much as we want. But we have to be careful with this. So the thing is, we can, with numeric types, you can do a lot of fancy things. So for example, I can actually store this num inside of num2. So I could do something like this. I could say num2 is assigned the value of num. Oops. And what does that actually do? It says, go to memory, give me the value, the current value of num, which is 5, and store it into the variable num2. Now when we run this, we should get 5 on both outputs. And we do. Let's try and reverse that. Let's say let's assign num equal to num2. And watch the difference. It fails because it says we can't convert type double to int. And the problem is that double takes up 64 bits of space. It simply can't fit. We're trying to stick a square peg in a round hole. Let's modify things for a second. Let's change this to a float. We have to put a little f after that so it knows that it's a float. Now let's see if we get the same problem. And we do. And the reason being, even though they're the same size, you can't put the decimals in there. The integer can't handle the decimals. So we have to make sure that we match types. You can put smaller types like byte and int and float up the chain. So a byte can go into an int, a float, or a double. An int can go into a float or a double, and a float can go into a double. But you can't put a double into an int or a byte. You might be able to put it into a float if it's small enough, but not necessarily. It depends on the data you're working with. So you got to be conscious of this. Next up, let's play with some strings. So I'm just going to, we'll leave that for now. We'll leave those things alone. Let's fix this code so we don't break anything. We'll just get rid of that line of code actually. Let's create a string. Let's say string user name. And we're going to set username equal to Bill. And we're going to display that down here, console.writeLine. And we're going to display name, colon, plus Bill. Oh, I don't want to actually write the word Bill. I want to use the variable username. Great. We should be able to do that without a problem. We hit run. And we get our two numbers. And we get Bill. We could do the same thing with a bool. So let's say bool is valid. And we're going to set this equal to false. The actual literal value false. And we should be able to do something similar. I'm just going to copy and paste this line because I'm lazy. And we're just going to write valid. And we're going to output is valid. Let's see what we get here. We can see it actually outputs the word false. So this write line command sees this Boolean and it interprets it and modifies it to something that's readable for us. Okay. So now we've looked at the different data types. Let's play with that a little bit more in terms of the string. Let's say I wanted to display only the first character of username. So I could do that using square brackets. Let's move my cursor there, the big purple cursor. We could do that with square brackets, and all we have to do is specify the address of the letter we want. Now the username is Bill, so each letter has its own address, its own index. So the first letter has the index 0, then 1, 2, and 3. So if I write output username at 0, and we run this, we should just get the B, which is what we did. Let's say I want the last character. Let's say 3. And we run this, and we get the L. Now, we're assuming that it's the last L. What happens if I do something like this? 4. You make the mistake, oh, there's 4 letters in there, so I want the last one, so I'm going to output 4. You're going to cause a problem. You get an index out of range exception. It basically means you went past the end of the string. You went out of the range. And that's because you tried to access an index that doesn't exist. 0, 1, 2, 3. Just because there's 4 characters doesn't mean there is an index 4. 0, 1, 2, 3. Everything starts numbering at 0 in C#. So there's another command that we can use when we're talking about strings, and that's the length command. So let's say I don't know what the value of my the text of my username is. Maybe I got it from the user or something like that, but I still want to output the last character. So I could do this. I could say username dot length. Oops, can't spell. So it's just a property of the variable. Now if I run this, it's going to give me, well, what's the length of the string? That tells me how many characters are in it. So there's 4 characters in this. So the 4 is going to get substituted for this. Well, that puts us in the same situation we were just there a second ago. We're going to go past the end of the string. And we do, because there is no index 4. So whenever we want to do this, we're just going to subtract 1. The user length minus 1. That will always give us the last character. So we see we get the L. Just to test this, let's try this. Bill S. Preston Esquire. We should get that little e. And we do. So now we have strings that we can manipulate. We can access individual characters. We can do a whole bunch of other things, but I want to wait on that until we start getting into the conversion lesson. So that's it for now, and we'll continue next time.